Fact 1. The sun will eventually destroy Earth. 100% proven science. This is not a movie theory, not a conspiracy, and not speculation. It is a scientific certainty agreed upon by astronomers, astrophysicists, and space agencies around the world. One day, the sun itself will make Earth uninhabitable and eventually destroy it. The only unknown factor is when, not if. The sun is not a calm ball of light. It is a massive nuclear fusion reactor that converts hydrogen into helium every second. This process releases an enormous amount of energy, which makes life on Earth possible today. However, this same process is also slowly changing the sun in dangerous ways. Right now, the sun is in a stage of its life called the main sequence phase. Even in this stable phase, scientists have confirmed something alarming. The sun becomes about 10% brighter every 1 billion years. That increase in brightness means more heat reaching Earth. The change is extremely slow, so humans don't notice it in daily life. But on a planetary timescale, it is catastrophic. According to climate and astrophysical models, in about 1 billion years, Earth will receive so much heat that the planet's natural balance will collapse. The oceans will begin to evaporate, increasing water vapor in the atmosphere. Water vapor is a powerful greenhouse gas, which will trap even more heat, creating a runaway greenhouse effect. As temperatures rise further, Earth's rain cycle will break down. Clouds will no longer function normally, and rainfall patterns will disappear. This is the moment when life starts to collapse. Plants will be the first major victims. High temperatures prevent photosynthesis, the process that produces oxygen. As plants die, Earth's oxygen supply will begin to fall. Insects and animals that depend on plants will follow. Humans may survive longer using technology, but scientists agree oxygen loss makes long-term survival impossible. Earth will still exist physically, but it will become a dead planet, similar to Mars, hot, dry, and lifeless. But this is only the beginning. After several billion more years, the sun will run out of hydrogen fuel in its core. When this happens, it will enter a new phase known as the red giant stage. During this phase, the sun will expand dramatically, growing so large that it will engulf nearby planets. Scientific simulations show that Mercury and Venus will be completely destroyed. Earth's fate is uncertain, but many models suggest that Earth could also be swallowed by the expanding sun. Even if Earth avoids being pulled directly into the sun, survival is still impossible. The sun's extreme heat will strip away Earth's atmosphere, boil any remaining water, melt the planet's surface into molten rock. At that point, Earth will no longer be a planet capable of supporting any form of life. What makes this fact terrifying is that nothing can stop it. This is not a disaster that can be prevented with technology, artificial intelligence, or space travel. It is part of the natural life cycle of stars. Every star, like our sun, ends this way. Some people believe humans could escape by moving to another planet, but even that is not a permanent solution. When the sun dies, the entire solar system will be affected. Any planet orbiting the sun will face extreme changes or destruction. Fact 2. Asteroids are a real and proven threat to human civilization. Asteroids are not a science fiction danger. An ongoing threat that scientists actively monitor because Earth has already been hit before, and it will happen again. The only uncertainty is when, not whether. When the asteroid hit, it released more energy than billions of nuclear bombs combined. Massive earthquakes shook the planet. Mega tsunamis swept across oceans. Firestorms burned entire continents. Plants died. Life nearly ended, and that was not a one-time event. Today, Scientists have identified millions of asteroids moving through our solar system. Thousands of them are classified as near-Earth objects, meaning their orbits bring them dangerously close to Earth. Among these, some are labeled potentially hazardous asteroids. The word potentially does not mean harmless. It means their size and orbit are capable of causing massive destruction if a collision occurs. NASA and other space agencies track these objects constantly. They have confirmed that asteroids pass between Earth and the Moon regularly. Some are detected only days or weeks before close approach. Smaller asteroids often go unnoticed until after they pass. In 2013, a relatively small asteroid exploded over Chelyabinsk, Russia. It never hit the ground, yet the airburst released energy equivalent to 30 Hiroshima bombs. Over 1,500 people were injured, mostly from shattered glass. That asteroid was not detected in advance. Now imagine one just a little bigger. Scientists warned that an asteroid only 140 meters wide could destroy an entire major city. One 1 kilometer wide could collapse global civilization, and an asteroid like the dinosaur killer would cause mass extinction again. What makes asteroids terrifying is speed. They travel at tens of thousands of kilometers per hour. If one is detected late, there may be no time to stop it. Yes, space agencies are testing planetary defense systems. NASA successfully tested a mission called DART, which slightly altered an asteroid's orbit, but scientists are honest about the limitations. Deflection only works with years or decades of warning. Fragmentation could make damage even worse. There is no guaranteed defense system. Another chilling fact is that Earth's gravity itself attracts asteroids. Sometimes, an asteroid passing near Earth gets pulled into a new orbit, increasing the chance of a future impact. These are known as gravitational keyholes, narrow regions in space that can turn a near miss into a future collision. Scientists also know that impacts do not need to be direct hits to be devastating. An asteroid exploding in the atmosphere can flatten cities, ignite wildfires, trigger shockwaves across continents. Unlike climate change or pandemics, asteroid impacts are sudden. There is no slow warning, no adjustment period, no recovery time. One moment, civilization exists. The next, it may not. This is why asteroid impact remains one of the top existential risks listed by scientists. It is not fear-based speculation. It is based on physics, history, and direct observation of space. Fact 3. The Yellowstone supervolcano could collapse. Human civilization Yellowstone is not just a national park or a tourist destination. Beneath its geysers, hot springs, and forests lies one of the most dangerous geological structures on Earth. This is not speculation or exaggeration. Yellowstone is officially classified by geologists as an active supervolcano, and its eruption would be powerful enough to affect the entire planet. A supervolcano is different from a normal volcano. Instead of forming a mountain, it creates a massive underground magma chamber, tens of kilometers wide. When it erupts, it does not produce a simple lava flow. It releases thousands of cubic kilometers of ash, gas, and molten rock in a single event. Yellowstone has erupted before. Geological evidence shows at least 3 massive supereruptions, about 2.1 million years ago, about 1.3 million years ago, about 640,000 years ago. Each eruption reshaped the landscape of North America. Thick layers of volcanic ash from Yellowstone have been found across much of the United States, proving the scale of these events. If Yellowstone were to erupt again, scientists agree it would not end the Earth, but it could end modern human civilization. The immediate impact would be catastrophic. Within minutes, the area around Yellowstone would be destroyed. Everything within hundreds of kilometers would be buried under meters of ash. Cities would collapse under the weight. Infrastructure would be erased. Survival in the region would be impossible. But the true danger lies beyond the initial blast. Volcanic ash would be blasted high into the atmosphere and spread across continents. Large portions of North America would be covered in ash, thick enough to destroy crops, poison water supplies, collapse, buildings shut down, transportation, air travel would stop completely. Engines cannot function in volcanic ash. Communication systems would fail. Power grids would collapse. Even more frightening is the global effect. A super eruption would inject massive amounts of sulfur dioxide into the upper atmosphere. This gas forms particles that reflect sunlight back into space, causing global temperatures to drop. Scientists called this phenomenon a volcanic winter. During a volcanic winter, sunlight decreases, worldwide growing seasons shrink or disappear, crops fail on a global scale, food shortages spread rapidly. Even countries far from the eruption would suffer. Global trade would collapse. Food exporting nations would prioritize survival, cutting off supplies. Famine would not be regional. It would be worldwide. Modern civilization depends on stable climate, global supply chains, and constant energy production. A Yellowstone eruption would break all three at once. Some people ask whether scientists can predict or stop such an eruption. The uncomfortable truth is this: we cannot stop it. Yellowstone is constantly monitored using satellites, GPS sensors, and seismic instruments. Scientists track ground movement, earthquakes, and gas emissions. While this monitoring can provide warning signs, it cannot prevent an eruption. At best, it may give weeks or months of notice, not a solution. Importantly, scientists also clarify that Yellowstone is not overdue. Supervolcano eruptions do not follow schedules. However, this does not reduce the risk. Geological records prove that it will erupt again at some point in Earth's future. Another critical issue is human preparedness. There is no realistic evacuation plan for an event of this scale. Tens of millions of people would be affected almost instantly. Global systems are not designed to handle this level of disruption. What makes Yellowstone especially terrifying is that it is a natural threat beyond human control. No technology, weapon, or policy can stop us. Humanity could only react, and reacting may not be enough. The final scientific consensus is clear. Yellowstone is real. It has erupted before it will erupt again. We cannot prevent it. The question is not whether Yellowstone is dangerous. The question is whether modern civilization is strong enough to survive the aftermath. In the face of a supervolcano, human progress becomes fragile. Sometimes, the greatest threat to our world is not in the sky, but beneath our feet. Fact 4. Climate change is a slow but certain threat to human civilization. Climate change is often misunderstood as a future problem or a political debate, but in reality, it is a measurable, ongoing process that scientists have been tracking for over a century. Unlike sudden disasters such as asteroids or volcanoes, climate change represents a slow-moving but deeply destructive threat, one that could destabilize human civilization without a single dramatic explosion. Earth's climate has always changed naturally, but what makes the current situation different is speed. Since the Industrial Revolution, human activities, primarily burning fossil fuels like coal, oil, and gas, have released massive amounts of carbon dioxide into the atmosphere. Carbon dioxide traps heat, strengthening the planet's greenhouse effect. Scientific measurements show that global average temperatures have already increased by more than 1 degree Celsius above pre-industrial levels. That may sound small, but even slight increases in average temperature dramatically affects weather systems, oceans, and ecosystems. High temperatures reduce the human body's ability to cool itself, increasing the risk of heat exhaustion and death. Certain regions may reach wet bulb temperatures so high that humans cannot survive outdoors for long periods, even in the shade. Agriculture is especially vulnerable. Crops are sensitive to temperature, rainfall, and seasonal stability. Climate change disrupts all three. Prolonged droughts reduce water availability, while extreme rainfall causes flooding that destroys harvests. Scientists warn that staple crops such as wheat, rice, and corn may experience significant yield declines in a warming world. As food systems weaken, global hunger increases. Modern civilization depends on reliable food production and international trade. Climate-driven crop failures in multiple regions at the same time could trigger widespread famine, economic collapse, and political instability. The oceans are also under threat. As they absorb excess heat, they become warmer and more acidic. This damages coral reefs, which support marine ecosystems and fisheries that billions of people rely on for protein. Ocean warming also disrupts major currents that regulate Earth's climate, potentially causing abrupt, regional climate shifts. Climate change acts as a threat multiplier. It does not only cause environmental damage, it increases the risk of conflict, mass migration, and disease. Scarcity of water and food can intensify tensions between nations. Rising temperatures allow disease-carrying insects to expand into new regions, increasing the spread of infections. One of the most dangerous aspects of climate change is the possibility of tipping points. These are thresholds beyond which changes become self-reinforcing and irreversible on human time. Examples include large-scale ice sheet collapse or the debacle of major rainforests. Once crossed, these tipping points could accelerate warming beyond human control. Unlike many other existential threats, climate change is not theoretical. It is already happening. Scientists do not debate its existence. They debate how fast it will progress and how severe the impacts will be. Importantly, climate change is unlikely to destroy Earth itself. The planet will survive. What is at risk is human civilization as we know it. Stable societies depend on predictable climate conditions, functioning ecosystems, and reliable resources. Climate change undermines all three simultaneously. Fact 5. Nuclear war could trigger a global nuclear winter. Nuclear war is one of the most immediate and scientifically validated threats to human civilization. This is not speculation based on movies or fear. It is a scenario that has been studied for decades by physicists, climate scientists, and military analysts. When a nuclear weapon detonates over a city, it creates an intense firestorm. Buildings, vehicles, forests, and fuel sources ignite. Almost instantly, these massive fires generate enormous amounts of black carbon smoke, which rises high into the atmosphere. Scientists have modeled what happens if dozens or hundreds of nuclear weapons are used. Their findings show that the smoke would rise into the upper atmosphere, where rain cannot easily wash it away. Once there, it could remain for years. This leads to a phenomenon known as nuclear winter. In a nuclear winter scenario, thick smoke blocks sunlight from reaching Earth's surface. Global temperatures drop rapidly. Days become darker and colder. Summers shorten, winters become harsher. In some models, average global temperatures fall by several degrees, enough to disrupt agriculture worldwide. This temperature drop would not be localized. It would affect every continent. Crops require sunlight, warmth, and predictable seasons. Nuclear winter removes all three. Scientists warn that even a limited regional nuclear war could cause massive crop failures, collapse of food production, global famine affecting billions. Modern civilization is extremely dependent on global food systems. Most countries do not produce enough food to survive long-term isolation. International trade fills the gaps. In a nuclear winter, trade would collapse due to damaged infrastructure, political chaos, and food shortages. The result would not just be hunger, it would be systemic collapse. Another often overlooked factor is radiation. While radiation levels decrease over time, the immediate aftermath would contaminate large regions, making them unsafe for agriculture or habitation. This would reduce usable land precisely when food production is most critical. Nuclear war would also destroy electrical grids, communication networks, medical systems, transportation infrastructure. Hospitals would be overwhelmed or destroyed. Medical supplies would run out. Even minor injuries or infections could become deadly. Recovery would be slow, if it happens at all. One of the most disturbing conclusions from scientific studies is that nuclear war does not need to involve every nuclear weapon on Earth to be catastrophic. Research shows that a conflict involving only a fraction of existing arsenals could still trigger a global nuclear winter. This means that human survival does not depend on a full-scale world war. A smaller conflict, under the wrong conditions, could still end modern civilization. Unlike asteroids or supervolcanoes, nuclear war is entirely human-made. It is the result of political decisions, misunderstandings, or escalations. The technology already exists. The weapons are already deployed. The risk is not theoretical. What makes nuclear war especially dangerous is speed. Decisions could be made in minutes. Missiles could be launched based on false alarms, technical errors, or misinterpretation. History has recorded multiple close calls where nuclear war was narrowly avoided. Fact 6. Earth will eventually lose its oxygen. Suffocating most life, oxygen feels permanent. Every breath we take makes it seem like Earth's atmosphere will always stay the same. But science tells a very different story. According to geologists, biologists, and atmospheric scientists, Earth's oxygen-rich atmosphere is temporary, and one day it will disappear. When that happens, most life on the planet will suffocate. This is not speculation. It is based on Earth's geological history, chemical models, and observations of planetary evolution. To understand this, we need to start with a shocking truth. Earth did not always have oxygen. For the first half of Earth's history, the atmosphere contained almost no oxygen at all. Life existed, but it was simple, mostly microbes that did not need oxygen. Oxygen only became abundant around 2.4 billion years ago, during an event known as the Great Oxidation Event. That oxygen came from plants and photosynthetic organisms, which use sunlight to convert carbon dioxide into energy, releasing oxygen as a byproduct. Every breath humans take depends on this process. But this system is fragile. Scientists have discovered that Earth's oxygen balance depends on a delicate relationship between sunlight, carbon dioxide levels, plant life, geological processes. As the sun ages, it becomes hotter and brighter. This increased heat causes chemical reactions in the atmosphere that slowly remove carbon dioxide. At first, that sounds like a good thing, but it's not. Plants need carbon dioxide to survive. As levels drop, photosynthesis becomes less efficient. Eventually, plants can no longer produce enough oxygen to replace what is naturally lost through chemical reactions with rocks and gases. When plant life collapses, oxygen production stops. Scientific models predict that in the distant future, long before the sun becomes a red giant, Earth will experience a rapid decline in atmospheric oxygen. Once this process begins, oxygen levels could fall dramatically in a relatively short geological time span. For complex life, the consequences are fatal. Animals, including humans, require high oxygen concentrations to survive. As oxygen drops, breathing becomes difficult. Physical activity becomes impossible. Survival time shortens dramatically eventually. Mammals, birds, reptiles, and most insects would go extinct. The oceans would also suffer, as oxygen-poor waters cannot support fish and complex marine life. What remains would be simple, anaerobic organisms, life forms similar to those that existed billions of years ago, before oxygen filled the atmosphere. One of the most disturbing aspects of this process is how silent it would be. There would be no explosion, no impact, no sudden catastrophe. Oxygen would simply decline, generation after generation, until survival becomes impossible. Technology may delay the inevitable for a time. Humans could use artificial oxygen systems, sealed environments, or controlled habitats, but sustaining an entire planet artificially is unrealistic. Once global oxygen levels fall below a certain threshold, planet-wide survival is impossible. This process has been supported by geological records of ancient atmospheres, computer simulations of Earth's future, Studies of how stars affect planetary chemistry scientists also observe similar processes on other planets. Mars, for example, lost most of its atmosphere due to solar radiation and weak gravity. While Earth's situation is different, it proves that atmospheres are not permanent. Importantly, oxygen loss would happen before the sun destroys Earth completely. That means the planet could still look blue and intact from space, while being deadly to breathe on.